Uh, okay, so the electricity production is one of my favorite ones, and it is actually really cool because if you go to NASA's website, there's a whole bunch of problems that need to be solved for human space settlement in their program. It takes a little while to find, but when you do find it, uh, power is one of the main ones. Now we only produce 128 kilowatts of power on the International Space Station. Uh, Now, in contrast, our dams on Earth, our hydroelectric dams using water to push the turbines, produce hundreds of megawatts of power, and they can power whole cities. So, another one of the problems that was listed on the NASA problems site for human space settlement is the cosmic radiation, and this is also on, like, of course, astronomy, TV, and stuff like that. So, having hundreds of megawatts of power is obviously going to give us enough. Even just spinning these magnets around in the copper probably is going to give us the sort of electrical electromagnetic field that we have to block the solar radiation that the Earth also has from its internal dynamo at its core. Now, a dynamo is simply when metals are spinning around each other. When a magnetized metal is spinning a magnet is spinning within a coil of copper wire, and is dragging the electrons, the valence or outer electrons, from each copper atom to the next one, and it creates a current of electricity going through the wire, and then the wire goes out to wherever. So you have a giant core of copper wire, a giant core of copper wire, just like the alternator in your car if you've ever worked on one or rebuilt one, right? So you have a giant core of copper wire, the same thing that's in a dam turbine, and then a magnet that's moving it. Now, the properties of space give us the ability to lift a lot, right? Like, if we're on the moon, we can lift a lot more weight because of the lower G. Alright? I assume. So, we're a lot stronger in space, right? I guess. But if this is the dynamo we're trying to push, and the tip of this pen is us, and we go to push it, we're only going to push ourselves off of it with that extra strength. So we're going to go pretty far when we push ourselves off. The key is to make ourselves bigger than the dynamo. And we do that by attaching ourselves to a larger mass. So this would be, like, say, the steel bottom of our mass, and our dynamo on the top. Now, what I envisioned was something like a hemisphere with various pulleys going up and down it, up and down the walls. So, like, a hemisphere with pulleys, right? And then you got little human workstations at each one, where we're going like this, and these various machines are turning a massive magnet within the coil in the center of our hemisphere. So that is the first zero gravity machine, I suppose, and it will produce electrical power, using human beings or physical labor as the water in the dam. Instead of using water to constantly push it, we use human beings attached to a larger mass to push a very large magnet, a very powerful magnet, around in a very large copper coil. Now, the reason that we have to do a constant physical force, such as water, gas, like in your car, in your alternator, or with human beings, like in space, the reason why we have to use a constant physical force is that there's something called electrical resistance. So as those electrons are pulled, to each next copper atom, it's the same charge. Every electron has this exact same charge, right? So the equal charge resists itself. So no matter how much physical force you're putting in, I mean, you have to put in physical force to keep moving those electrons, or they push back, eventually making it stop. So you can't just take, like, say this is my coil of copper wire, and this is a power drill, right? And I just spin the magnet in space, and because of zero gravity, it's going to spin forever. It doesn't work that way because there's resistance. Even though it's a vacuum, you have that electrical resistance in space. Okay? So, that is my concept for deep space power production. It produces megawatts more. It works at any distance from any star, even in deep space, even between stars. It will work on low gravity moons and low gravity planets. And the low gravity is so important to me for finding the resources that are required for the entire executive outline, because of the cost in strength and power, and because I'm only using, say, if I'm getting my fuel from Venus, I'm only getting CO2. If I'm getting my fuel from Neptune, I'm only getting the gas that it is. So I can't always, I can't light CO2 on fire and turn it into a fire rocket. I can produce a hybrid rocket engine if I extract the oxygen, right? And then I can use a solid fuel and just push oxygen through it for the oxidizer. But besides that, if I want to still have universality, to be able to use every single gas planet in the galaxy or in the solar system, then I'm going to only want to use a system where it's a compressed gas rocket, a CO2 gun. Okay? It's basically a giant CO2 gun rocket that I'm using to fire my spaceship. Now, we could use our fuel to push our turbines, just like we push our spin-fired gravity decks. Now, our spin-fired gravity decks, we fire it once, and now it's going to go that 1G forever, So we're going to go that 1G forever, and we don't have to fire it again. But because of electrical resistance, we have to continue to fire the rockets over and over again. Oh, and the low gravity. The reason why I wanted to use low gravity is because they're not these massive, kerosene and oxidized kerosene rocket fuel that give us the kind of push that we need to get off of a 1G. So when I'm looking around, I want to find resources where it's just, 0.16G like the moon, 0.6G like Venus. This is how I can use my fuel to land and take off, even though it's only CO2. Or even if I'm using, say with the rapid advanced deployment strategy, I place rocket fuel into space. If I'm using that, then I still want to go for the resources on the lowest gravity moons possible, because it's going to be the least amount of fuel. So I'm kind of all over there with this one, but the whole concept of the zero gravity turbine is its universality, and its ability to produce electricity at any distance from any star, like I said, or between stars, like I said. And also it gives us an internal economy. It gives us a labor force in space. So it forces us to use manned missions. We have to have a crew to push this. So I'm going to have what? I'm going to have 100 guys there. I need 100 beds on a gravity deck now. I need a lounge that can accommodate 100 people, or at least, divide that by their shifts. But they're getting paid to support the survival of the crew. Everything that we're doing here is now centered around the survival of a large group of population, and it begins with labor class. It begins with the labor class that produces this power. It doesn't begin with the scientist. It doesn't begin with the billion-dollar robot. This is not Mech Warrior on Mars. This is production and expansion of life into the universe.